Let's look at a graphs and transformation question from an exam. Going to be testing you a bit on the ability to, draw graphs correctly and draw the graphs of transformations. It really is a useful skill, and once you can get the hang of drawing graphs effectively, then you've really gained yourself a useful tool in answering a lot of questions, both in maths and in sort of real world applications. So here's a sketch of a curve. Initially, you're not told what it is, so don't worry about what it actually is, other than the fact you're given two coordinates, A and B, which are the crossing points here. And then you're asked to, on separate diagrams, sketch the modulus of it, sketch the inverse of it, and correctly translate the crossing points A and B. After that, you're then going to be told precisely what the function actually is, and you're going to have to find the range of that function based on the domain, which you're given here, and you're going to have to then calculate the inverse of the function. Okay, it's nothing too tricky. Give it a go. Pause the video now. Okay, so our first one, mod of f of x. So let me just get myself a pair of axes ready. In this case, you've got the function. Let's see how it was originally drawn actually. It's originally drawn like this, and then continuing on like that, and then going along like this. And whether that's an asymptote or not, we don't know yet, but it doesn't really matter. Okay, and the thing now is, when you're taking the mod, what you're going to have to do is everything below the x-axis is going to be flipped vertically. So in this case, it's going to become this new red function. Let me just make sure I can draw this appropriately. It goes like this, crosses and continues here. Okay, the red function is our correct drawing for this thing here. Okay, and in terms of the the crossing points and what's relevant, well, this one's going to stay the same. That's still a half ln k 0 as it was on the original diagram. And this point here, well, down here the y value was 1 minus k. Let me double check that, was it? Yeah, it was 1 minus k. So up here it's going to be the negative of that, the negative of 1 minus k, k minus 1. So as an actual fully fledged coordinate, let's write it correctly, it's still at an x value 0, but we've got k minus 1 as the coordinate. And then if we just get rid of this, which we don't need anymore, that is what your function should look like. Hopefully slightly better drawn than my sort of squiggly lines, but along those lines, that's what your function should be, with these as the relevant crossing points. Okay, let's look at B. So for B, again, let me have an attempt at drawing what it originally looked like. It was something like that, continued along, and then like this. Okay, for drawing the inverse, remember, it's all about picturing that y equals x line, the invisible diagonal line. Okay, and you want to effectively draw your inverse as the yellow original line reflected in that one. So tilt your head a bit, draw the reflection, and then let's think about the relevant points. So this green crossing here, that is a translation of what was originally over here, and this blue crossing here, that's a translation of what was originally there. And all it is the x and y coordinates swapped, right? So if here we originally had half ln k 0, then here we're going to have 0 half ln k for that point there. And here we originally had, what was it, 0, 1 minus k. So here we're going to have 1 minus k, 0. And then we can get rid of the yellow line. And that's our inverse. That's what the inverse function should look like. Okay, next, I'm doing these together because they're related to the same question. You've got the function now. You're being told it's e to the 2x minus k. Don't need the graph now. What's the range? Well, what we do need to know first, if we want to know the range, you need to know the domain. So what was it? The domain, if you go back and look at the question, it said that x belongs to the real numbers. So in other words, it's every possible value. So then you need to ask yourself, when I plug in every possible value into this x here, what are my possible outputs? So to formally say what's going on here, let's think about the extremes. What happens as x goes to infinity? So when x gets absolutely massive, so when x is 10, x is 100, x is 1000, what's happening to the number as a whole? Well, it doesn't matter how big k is. I don't actually know what k is, but no matter how big k is, this exponential function is always eventually going to be bigger than this. So this whole thing is going to be going to infinity. So f of x, formally, and this is formal notation, we can say as x goes to infinity, f of x goes to infinity. And then, what about the other direction? As x goes to minus infinity, so x gets really, really small and negative, what's happening? So this e to the 2x, well, if you think about it, e to the power of something very, very small, and by small I mean negatively small, so minus a million, minus a billion, minus a trillion, this is going to become 0, or effectively 0. So therefore, as a whole, f of x will be going to 0 minus k, which is just minus k, isn't it? Okay. Now, I said you didn't really have to look at the graph, but it's important actually to know what's going on in between these two things. Just because we've tested the two extremes doesn't mean we fully understood the range. We need to just double check. So if I do look at the original graph, we can see that actually the graph is always increasing. It doesn't sort of go up and down. So does it match what we've just said? Well, as we go to infinity, we go to the right. What's happening to the graph? Well, it seems to be going up to infinity. That makes sense. What's happening as I go to the left? As I go to negative infinity, it seems to be flattening out at a specific value. And in this case, we just showed what that was. It's flattening out to become minus k. Right, or it's getting infinitely close to minus k. Right, that's what we showed here. So that's our range. The smallest it can be is minus k, or just above minus k, and the largest it can be, there is no limit. So to state the final answer then for part C, f of x is simply bigger than minus k. And that's all we need to write. The right hand side, we don't need to put anything. We don't need to say less than infinity. That wouldn't be correct notation. We just say it's bigger than minus k. So then the fact that it's less than infinity is implied. It's implied that it has no upper limit. Okay? So that's the answer to part C. To do the inverse, let's use our usual trick of assigning the function a name like y, and then flipping the names. So flipping the name of the function with its variable, and then aiming to find the y as the subject again. So I've added k to both sides. Now I'm going to take a logarithm of both sides. The log of e to the power of something is just that something. I'm going to flip it around and divide by 2. So we'll get y equals a half ln of x plus k. And that's our answer. You might also potentially write it like this, because if I take that half on the outside, I can make that a power of the inside, and x plus k to the power of a half is just square root. So these two answers are equivalent. Personally, I think this one is a lot nicer because square roots can get nasty. But either one of these That is your correct answer. That is the inverse function of f.